domestic wiring or domestic circuits. Okay, domestic electric circuit, of course, no need to write that. Domestic electric circuits or domestic electric wiring. What happens? The government supplies us the power. The electricity board supplies us the power which is generated in a hydroelectric plant or the thermal power plants, and it comes in 3 wires. One is phase or live wire, second is neutral, and third is earth. You might have heard electrician always asks, if the earthing is proper for this. If earthing is not proper, you may feel the shock. Okay, so that earthing is there. Generally, this phase is by red color. The neutral is generally given by green or black color. Neutral is given by black. In our domestic wiring, neutral is generally of black color wire and earthing is generally of green color wire. See, wire is same, only the insulation color changes. Okay, you can attach the red color wire to neutral, no harm in that, but the international notation, because the red is the color of danger and live wire, this phase is always danger, because the potential difference between phase and neutral, the potential difference is generally of 220 to 250 volts. It's a very high current, high electric current, and if you feel the shock, then it can be very dangerous. Okay, so from electricity board we get phase, neutral and earth to us. Maybe underground cabling or overhead cablings, properly insulated wires. The phase, which is live wire, is generally showed or insulated with the red color coating. The neutral is generally black colored wire and earthing is generally green color wire. The potential difference between phase and neutral is around 220 to 250 volts. How generally this comes to us? First of all, the phase comes here. We have first fuse here. The phase first comes to fuse, then it comes to meter, electric meter. We all have the electric meter which measures how much electricity you are consuming. It will come to that meter. Now from meter it comes to your main switch. On main switch there are so many, there can be extra fuses and buttons, and from there it is distributed to our household, maybe fan, lights, fridge, whatever it is. And that distribution is, suppose these are 3 bulbs, that distribution is always parallel in circuit. So my neutral comes here, it goes to meter, from their switch, and from there, and my phase goes from here The circuit is generally like this. The schematic diagram of a general domestic electric circuit is like this. The potential difference here, the potential difference between phase and neutral is generally 220 to 250 volts. Now the potential difference between any appliance, now this is a bulb, but if you have the TV, mixer, fridge, the potential difference between any of the appliances is same because they are attached in parallel. Now what is the use of this earthing, the third wire comes, which is earthing. What is the use of it? Okay. Whenever this earthing comes from electricity board, nearby our house or nearby our society, deep in the ground, one copper plate is buried, and that earthing is connected to that. One copper plate is buried, okay, and that earthing is connected to that. And for the bigger instruments like your fridge or the TV, where the metallic casing is there, washing machine, mixer, microwave oven, toasters, wherever these are attached, you have generally 3 holes. We call it as the 3 pin. One is for phase, one is for neutral, and one is for earthing. Now this earthing is attached, it's a jumped, is attached here. Why it is so? Because whenever, suppose now in this case this is not a bulb, because for bulb we don't need much of the earthing because non-metallic cases are there. But for the mixer, washing machine, fridge, toasters, what happens? There are the metallic cases. In case, suppose the insulation of the wiring, inside wiring, is melted somewhere and it touches the body of your mixer, washing machine, fridge, what will happen? Suppose that phase is touching here, so this surrounding metallic body becomes live, and if you touch your bare hand to this, what will happen? You will feel a severe shock. Okay, so in this case, this earthing is generally connected to the body, metallic body of that particular instrument, and it is directly grounded. So it becomes neutralized and you will not feel the shock. So if the earthing is not proper, if the earthing of your building, of your domestic electric circuit is not proper, it may happen that sometimes you may feel electric shock by just touching the instruments. So that is why the earthings are there. Earth wire is there. This is your earth wire. This is your phase, and this is your neutral. And as a whole, this will be called as the schematic diagram of domestic electric circuits. Okay, we will see what is the use of fuse, what is the use of meter. Meter, everybody knows that we use to measure how much electricity you are consuming. For that, meter is there. But for what? The fuse. We will see why the fuse will be used. Okay, in this case, right now, just remember this schematic diagram. Okay, on this main switch there can be extra fuse also. Here the main fuse is there, which is coming from the electricity board. Then the meter is there. To the main switch, again we install some fuses in our household as a main switch. Whenever we go out, we just switch off the fuses or switch off the main switch, so that this connection is so that we just terminate this connection here. The electricity will not be present after the main switch once you switch off the fuse. Either you take out the fuse or switch off the main switch. So the electricity will not be there in the further part from your main switch. So right now you just understand this schematic diagram. You may have to draw this schematic diagram in your exam. Again I am telling you, you should not use colored pens or pencils in your paper, because green color is for moderator, your red color is for paper checker. So you have to use only blue or black. Okay, do not use, I am just showing you these lines in color to make you understand. Okay, do not use the color pencils or color pens in your exam. So this is the domestic electric circuit. So what precautions we should take? First of all, the fuse must be applied before meter and in your main switch also. Why the fuse? We have already learned in the chapter 4 why the fuses are used. In short, I will tell you, whenever the current flows through this, for current flow through the conductor, there is a resistance, and because of the resistance, the heat is generated. Okay, if this is overloaded, then it goes beyond the 250 volts. What will happen? The more current will pass, more friction or the more resistance will be there, and more heat will be generated. The fuse wire here, the fuse wire is made up of such a material, nichrome or low melting point material, that if it gets overloaded or overheated, it will melt and this connection is breaked, and it will save all your circuit from fuse onward. Okay, then what other precautions we should take? The earthing must be very proper. I already told you what is the use of the earthing, why it is used. The second thing, you should never touch the live wires. You should never touch the phase with your bare hands, because you know the earthing is there buried inside, the third wire is there. So if you touch the phase with your bare hands, what will happen? The electric current will pass through your body to the earth, the circuit gets completed, and you will get a severe shock which is deadly in some cases. So you should take care that never touch the phase with your bare hands. Okay, avoid the contact with the ground. So wear some rubbers or plastic sleepers, or stand on some wooden box or wooden stool, or use the heavy rubber or plastic gloves which is of the highly insulative material to touch this. It is always better, if you are working on this part, always switch off the main switch, so that electric current will not be there and you will be saved from severe electric shock. Now whenever the lightning is there in the sky during rainy season or maybe in the summer sometimes, you should always switch off the main switch to save your electric equipments from lightning. So these are some of the safety measures, what precautions we have to take in case of our domestic wiring. Now we should always check time to time whether our wires are proper or not, because if you use the low quality wires, what will happen? Because of the heat generated, that insulating material maybe of the lower quality will get melted and the live wire becomes open, and if it touch some metal part or if it touch the weight floor or the weight wall, you will get severe shock in this case. So these are the precautions we should take for our domestic electric circuits. We have to learn two things. One is short circuit. What do you mean by short circuit? Short circuit means if the phase and neutral comes in contact with each other, it touches each other. You might have seen in the films that some people take two wires they remove the bulb, they take two wires, live and neutral, and they touch each other and whole electricity goes off. Okay, what happens in that case? If you touch the live phase and neutral to each other, the resistance, there is a potential difference between this phase and neutral around 220 to 250 volts. What will happen? As soon as the phase and neutral are touched to each other, the resistance between them will be approximately or nearly zero or very less, and a huge amount of current will flow through the circuit, and this huge amount of current which is flowing through the circuit will generate the huge amount of heat, and this heat can literally cause a fire, and your whole circuit, your whole household wiring can be burnt, will catch fire, and in that case any wooden material, gas cylinder, everything will catch fire and the whole house will blow off. So we should always take care that phase and neutral should never come into contact with each other. So you have to take care of this. Second thing we have to learn is about overloading. Many times you may experience in your house also. Suppose light is there, bulb is there. You are sitting in a drawing room and one bulb is glowing. Somebody goes for taking bath and switch on the geyser. What happens? The bulb suddenly becomes dim or it fluctuates, right? And when the geyser is again switch off, the bulb glows brightly. Why? Because every electrical instruments have some power rating. Your fridge, your mixer, your geyser, and your electric motors, air conditioners have very high power ratings. If many of such instruments are started simultaneously, they will consume the high amount of power, and in that case it will get overloaded. In case of overloading also, either a huge amount of heat is generated, and if you have fuses, the fuse will go off. Suppose on one switchboard there is one fuse is there and 3 AC are connected to that, and if you switch on the 3 ACs simultaneously, what will happen? Because of the high power rating, the heat is generated and the power what we are supplying is not sufficient to run them simultaneously. The heat is generated in the circuit and fuse will go off. Nowadays you will not see the fuses. Initially, in earlier days, the fuse is something like your button, and in this one fuse wire is attached. Okay, so whenever this fuse is there, what will happen? Due to heating, this wire will melt, circuit is break, and all your things are saved from burning. Nowadays on your main switches or on your house, the fuse wire is hardly used. Generally we use the circuit breakers. Nowadays the circuit breakers are used. So whenever the short circuit or overloading is there, that button or that switch is automatically turned off. So you don't have to change the fuse wire also. You have to just switch on the fuse again by switching off all the instruments. So this is about the short circuit and overloading. In short circuit, phase plus neutral, which will cause your short circuit, and overloading means too many high power instruments or like your AC, fridge, geysers are switched on together simultaneously, which consume high power, and because of that the fuse goes off. The heat is generated and fuse goes off. If the fuse is not there, again there is a danger of burning the wires itself. Okay, so we have to consider while doing our domestic electric circuits to take care of whatever the precautions I told you initially, and then we have to take care of short circuit and overloading also. Both we have to take. Okay, we have to save our house from overloading also, and we have to save our house from short circuits also. Now this job nowadays is done by the circuit breakers. Okay, so this is all about the domestic electric circuits, and here we finish this chapter, and as a next topic we will see the question answers. Thank you.